This is Christina from Loyola Ecom College of Engineering. Today, we are going to look at the fundamentals of fuzzy logic. A large amount of data leads to large amount of information. Where there is large amount of information, there will always be a level of uncertainty in the information. Fuzzy systems is a soft computing technology that will help you find the best input that produces the required output. Now let us first decide or understand what is uncertainty. I'll give you an example. He drives slowly. The term slowly is very subjective. How slow he is? Where do I define slow? What is the value for this word slow? So if I'm going to set the speed is less than or equal to 20, I say it is going to be slow. So what is the derived meaning from this? If the speed is greater than 20, it means he is fast. So does it mean that a person who is driving at 21 km per hour is fast? No, right? Does it mean that a person who is driving at 20.1 is fast? No. So there is definitely uncertainty in it. So how do we address it? So this leads to classifying the sets into two categories. One is the crisp set, the other is the fuzzy set. Crisp set is what I've been telling just now. So when I say S is equal to 20, so when I define slow, from 0 to 40 kilometers per hour it's slow, from fast 40 to 70 kilometers it is fast. So I'm defining a concrete boundary here, which is going to say like from 0 to 40 it is slow, and from 40.1 to 70 it is fast. So again, it is not very clear. So 39 is slow, but 40 is slow, and 41 becomes fast, or 40.1 becomes fast. So this doesn't give a clear meaning or a clear demarcation of the two classes. So this is definitely a very big drawback when we try to convert it or apply this concept in any kind of real world problem understanding. So we are going to move on to the next category, which is called as fuzzy set. So in order to reduce the complexity of comprehending this, a vagueness is introduced in the crisp set. So just apart from the numbers, I'm now going to define a degree of membership to this. A degree of membership for each of the value in my crisp set. So let us look at it in more detail. So here the membership value is going to denote the sense of belonging. How much do I belong to that particular class? So we are going to take another example here of a set of ages. And I'm having 6 fuzzy variables: infant, child, adolescent, adult, young, and old. Now I'm going to define membership for each of them. So let us look at the table now. A kid who is 2 years probably belongs more to the category of infant. So here the degree of membership becomes 1 for infant. He is not a child, so 0. Adolescent, 0. It is young, so the degree of membership is 1. Adult and old, they have no connection, so it is going to be 0. So a kid of age 4, infant, it is going to be 0.1, and child is 0.5. Is it understandable to you now? Because it belongs lesser to infant, because I can no longer call a child who is almost about to go to school as an infant. He or she has more belonging to this particular class child rather than an infant. And definitely he or she is young, so here I can give the membership value as 1. So when you look at another example, at the age of 10, definite no infant, so it's going to be 0. And child, yeah, maybe yes, maybe not. So I can give a value here, a 0.8, a 0.7. And again, adolescent, though the teens, 13, 14, 15, we call it as adolescent, it is nearing, 10 is nearing the adolescent age. So I can define here with some amount of membership like 0.2 or 0.3. So by this way, by this idea, we are not concretely saying or concretely putting it into one class. So there is an amount of vagueness. So I can call a kid, I can call a person with an age 10 as a child, but also as an adult with some kind of belonging. So here we are going to introduce the vagueness through the degree of membership or through the membership value. So this is how fuzzy sets are described. So the same example has been repeated here. So as per the table 1, a person with age 30 is 60% young and 100% adult. A person with age 40 is 40% young and 100% adult. So this kind of classification can be used in many real-time applications. Few of those applications are, they're used in water heaters, they're used in air conditioners. A more detailed example of how to apply the fuzzy logic can be seen in another video. Thank you very much.